What's this paper about? This paper, written by some researchers in 2021, looks at something called solar geoengineering, or SGE for short. It's a way to cool the Earth by reflecting sunlight back into space, kind of like putting a giant sunshade over the planet. Think of it as mimicking what happens after a big volcanic eruption where particles in the air block sunlight and lower temperatures. The paper explores how using SGE could help with climate change, but it also digs into the uncertainties, things we don't fully understand about how it works or how the climate responds. It asks, if we try SGE, will we learn more about it and the climate, and how should we use it? Why is this tricky? SGE sounds cool, right? But there are two big unknowns. First, we're not sure how well SGE will actually cool the planet. Will spraying particles into the atmosphere work as well as we hope? Second, we don't know exactly how sensitive the climate is to carbon dioxide, basically, how much warming a certain amount of CO2 causes. These uncertainties make it hard to decide how much SGE to use or whether it's even a good idea. The researchers built a computer model to figure out the best way to use SGE while considering these unknowns. They also looked at how using SGE might help us learn more about it and the climate over time. What did they find? Here's the surprising part. Using SGE doesn't always help us learn more. In fact, for small or medium sized SGE projects, it can make things less clear. Why? When you use a little bit of SGE, it cools the planet just enough to make temperature changes harder to notice. It's like trying to hear a whisper in a noisy room. The signal gets drowned out by random weather changes. Um, this makes it tougher to figure out how effective SGE is or how sensitive the climate is to CO2. Only a massive SGE project, way bigger than what's practical, would create a clear enough cooling effect to help us learn faster. But big projects like that are costly and could have harmful side effects like damaging the ozone layer or not fixing problems like ocean acidification caused by CO2. Another issue is that SGE adds its own uncertainty. If the planet warms unexpectedly, is it because the climate is super sensitive to CO2, because SGE didn't work as well as we thought, or just because of random weather? This extra noise slows down our ability to learn about the climate. So, should we use SGE? The researchers ran a bunch of simulations to see what the best approach is. They found that a little bit of SGE is usually a good idea, but not because it helps us learn. It's more about balancing the costs and benefits. SGE is relatively cheap and can cool the planet quickly, which is helpful if climate change gets really bad. But it's not a magic fix. It doesn't reduce CO2 levels, and it comes with risks. The amount of SGE we should use depends a lot on what we believe about the climate and SGE's effectiveness. If we think climate change is going to be really severe and SGE works well, we might use more of it, up to about 14% of the effort needed to offset CO2's warming effect. But if we think the climate isn't as sensitive or SGE isn't that great, we'd use way less, maybe only 1 to 4%. They also looked at another strategy, cutting CO2 emissions or abatement. This is things like switching to renewable energy or capturing carbon. Cutting emissions helps us learn a bit more about the climate, but it's a slow process because CO2 builds up over centuries. Still, it's a safer bet in the long run because it tackles the root cause of climate change, not just the symptoms. What's the big picture? The paper says SGE can be part of the toolbox for fighting climate change, but it's not something we should rely on heavily. Small SGE projects don't teach us much and can even make things less clear. Big projects might help us learn, but they're too risky and expensive to be practical. Plus, SGE doesn't fix everything. CO2 still causes problems like ocean acidification, and SGE itself can cause harm. The best approach depends on what we learn over time. If we find out climate change is worse than we thought, we might lean on SGE more as a last resort. But for now, the researchers suggest using a little SGE cautiously while focusing more on cutting emissions. It's like having a backup plan. You might use it, but you don't want to bet everything on it. Why does this matter? This is important for people making decisions about climate change, like governments or scientists. They need to weigh the pros and cons of SGE carefully. It's tempting to use it because it's quick and cheap, but it's not a cure all, and it might make it harder to understand what's going on with the climate. The paper reminds us to keep learning and adapting as we go rather than jumping into something we don't fully understand.